In this video, I'm going to introduce you to this new research about diffusion models without attention. This research has been carried out by Jing Nathan, Giotto, and Alexander. In recent advancement in high-fidelity image generation, denoising diffusion probabilistic models or DDPMs have emerged as a key player. Diffusion state space model or DiffuSSM developed by these researchers in collaboration with Apple has successfully replaced attention mechanisms in high resolution image generation, and that has achieved comparable or even superior results to current models measured in FID and inception scores. Another great thing about this is that it has reduced computational load, or in another words, lower total flops. The thing is that the existing limitation with this denoising diffusion probabilistic model is that the applications which come out as a result at high resolution present significant computational challenges. So all of these current methods like patchifying, expedite processes in UNet, and transformer architectures can work, but they work at in a very expensive way, and then their representation capacity also gets exhausted. This is where this diffusion state space model or DiffuSSM helps. This is primarily an architecture that supplants attention mechanism with a more scalable state space model backbone. As per researchers, this approach effectively handles higher resolutions without resorting to global compression, thus preserving detailed image representation throughout the diffusion process. Now, another cool thing is that, as I mentioned earlier, they also have done comprehensive evaluation, which you can even find on this paper, and I will drop the link in video's description. It- These comprehensive evaluations on both ImageNet and LSEN dataset at two resolution demonstrate that this diffuse SSM is on par or even outperform existing diffusion models. Now, if you look at this architecture of diffuse SSM takes a noised image representation from the left, which can be a noise latent from a variational encoder. Then in the middle it flattens it to a sequence and then applies repeated layers alternating long range SSM scores with hourglass feed forward networks. And this is not something which we have seen transformers or even in the UNet. And that makes it very unique. So this is it, guys. This is a quick introduction into this diffusion model without attention or diffuse SSM. If you have any questions or thoughts, please put them in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.